let's get started. So Ben, I think there's a bit of history here. Sampling is a tool that's been used in distributed tracing kind of since the get-go, but I'm curious about your personal history of sampling and tracing at Google. Like, how did it get started for you?
Yeah, that's a good question. Google's distributed tracing system called Dapper is something that I worked on kind of earlier in my career. That project actually began in, I believe, in 2004 as a kind of side project for a couple of researchers who joined Google, some of whom had joined from Microsoft, where they were under a non-compete to work on search. So they had to find something useful to do that wasn't search. And one of the projects they started, among others, was this prototype of what was basically Dapper. The idea is pretty simple. I mean, just for those of you who are joining who don't have much context on distributed tracing, it's a simple concept. It's just that you want to be able to follow a request as it propagates not just through a single process or service, but across service boundaries. So you want to do that automatically. At Google, there are a number of ways that the code had been built to make that easy, or easier anyway, because they had one single shared library in use everywhere for doing remote procedure calls and for even propagating context from thread to thread. Like, that was all really centralized, so they could instrument in one place and get distributed tracing to work just from a basic technical standpoint. Now, to answer your question, the immediate problem if you do that is if you want to record, some reasonable contextual information, let's say 500 bytes or so, about a request every time it touches a new service, and your service stack is 15 or 20 levels deep between the user making the request and the very bottom of the stack, which is how it was at the time at Google, and you're operating at above 1 million queries per second, is actually more like 100 million in some places. That's just a ton of data. And so the dollar cost of just absorbing it was high, and it also introduced overhead, both for throughput and the efficiency, and also for latency, which is really not okay, because a big reason you want to use distributed tracing is to understand latency issues, so you don't want to have an observer effect where you create overhead through distributed tracing. So the hack was, and I will call it a hack, was to just say, well, forget it. We're going to keep, when a new trace starts, we're going to flip a coin, and 1 in X times, we're going to keep this trace and propagate that decision to keep it all the way down the tree so that we keep the whole thing, or we're going to not keep it and propagate that decision all the way down the whole tree and be consistent about it. And it turned out we did some experiments, and X at Google, for the way that we implemented things, which is a really important caveat, X at about 16, it didn't have overhead. So, or at least the overhead was in the noise of the experiment. So it wasn't, it wasn't going to affect the application. But to reduce costs further in terms of just the dollar cost of running the system, we moved that number all the way up to 1024. And then when we decided to do a globally centralized database, we had to do an additional 10x. So it ended up being 1 in 10,000 transactions were actually kept and stored durably for interactive queries, historical queries, which is a pretty small fraction, obviously. And then the rest were discarded somewhere along the way. And thus we did sampling. So we wrote a paper about Dapper and published it. Well, tried to publish it. It got rejected by conferences more than once. And then finally we're like, forget it. We're just going to put this on the internet so people can see it if they want, in 2010. And the paper was actually initially written in 2006. It included the experiments from 2006 in it, basically, where we talked about sampling. And then that just became the way people solved the problem. The problem was dollar cost and throughput and latency overhead. Sampling is one potential solution to that. That's my big beef about this whole thing, is that it's not the only way to do it, and there are many ways to do sampling, and that's hopefully what we can talk about today. But that was my first exposure.
Yeah. So I think we can get into a lot of these topics, but real quick, with that kind of sampling with Dapper at that time, was it kind of a single purpose tool? Did it have a primary use case, and that's why that type of sampling was acceptable at the time?
That's a great question. And yeah, I mean, I think the main thing that people are trying to, there are two main use cases. One was just literally understanding what was going on. I mean, I think anyone who's operating microservices can understand the need to do so. I mean, no one person has the whole thing in their head anymore, too many people at the company, too many services per request. So just getting a sense of what's going on, being able to follow a request as it propagates is actually very valuable just from a discovery standpoint. But I think the main motivation was latency analysis, both especially steady state latency analysis. So basically profiling for end user latency and optimizing after doing that profiling. And that was hugely valuable for Google, and that there had been a lot of efforts to optimize things that were off the critical path, which will happen anywhere that you optimize that profiling, of course. But without distributed tracing, profiling the distributed system is almost impossible. It really is almost impossible. So that was the main thing that it was built for. And then, of course, we adopted it to do other things that ended up being more valuable than that. But that was the initial impetus.
Yeah. So we'll get into the different value propositions, but before we do that, and by the way, I think that was maybe a side effect of the Dapper paper, was because the initial use case was latency analysis, distributed tracing kind of got pigeonholed for a while. It's like, oh, that's just the latency analysis tool because you have to do this upfront sampling, which limits its usability in other areas, which isn't true, as we're going to get into. But I think that's like a little historical footnote there. It kind of got pigeonholed for a little bit.
Yeah, agreed.
But let's talk about like the different kinds of sampling broadly for people who aren't familiar, because there's all these value propositions and there's all these different ways to sample, and they kind of interact. And I was wondering if you could just go over what you consider to be the basic categories or types of sampling that all the various algorithms would fall into. Someone needed a rule of thumb of like what basic buckets they had to pick from. How would you divide them up?
Yeah, well, I will answer your question. Before I do, though, I just want to say I think a big part of my hope is that people don't need to understand this because it's so difficult to understand, especially the implications of these different choices in terms of use cases. But briefly, you have the tricky thing about sampling is that if you're in, you often don't know if a request is going to be interesting until it's already happened. But by the time it becomes interesting, much of the request has already taken place. So you have this issue where you have to make the sampling decision. You either need to keep the data around long enough to make retroactive decisions, or you need to make the decision up front, not knowing whether or not the request is going to be interesting. And you can try and come up with heuristics to determine, whether it's likely to be interesting or not, but it really doesn't work that well in practice to do that. So the basic options are what's called head sampling, which is to say to make a sampling decision before you know anything about what the request is actually going to do. So it's just kind of flipping a coin, which is what we did with Dapper initially. There's kind of like a local sampling decision you can make, tail sampling, where you say after the local request is finished, you could say, well, I had an error locally, not anywhere else. I'm going to decide to keep this particular span, this part of the trace, and then maybe I'll set a bit so as I respond up to my parents that they can keep what they still can, and you can kind of turn sampling on midstream, which doesn't work that well for reasons. Or you can try and keep the data around for seconds or minutes long enough to make a retroactive decision, keep or discard the whole trace, which I think is probably the most flexible, but also the most difficult to implement. And then there's a lot of things in between. But I would say like head sampling is the most obvious thing, the most basic thing. Tail sampling is good, but locally, but difficult globally. And then being able to keep enough data around to really make a completely retroactive decision about keeping or discarding is the most flexible, but also the most expensive.
Yeah. And because it comes up in opentelemetry and other places, so people will see it, there's also some sampling around just individual spans,
yes.
Right? Where you have a priority or some other mechanism, and you're just choosing to
yes.
randomly keep individual spans rather than a complete trace.
Yeah, I'll talk about that. I prepared some scribbling like on an iPad that I can go through that will cover that, I think. So maybe, do you want me to go through those things?
Yeah, let's go through that and hopefully like frame this in terms of like actual value, because I agree with you. That's the important part. What are you going to do with it?
Right. So sampling, scribbling. So I have a habit of scribbling things out on an iPad and then making Twitter threads about these. I'm actually going to put this into Twitter thread, hopefully later this morning. So this is kind of a preview of that stuff, but inspired by this webinar, because I realized there's just not that much out there that describes the stuff at a high level. So again, I really, the sampling discussion kind of infuriates me at a certain level, because it really should be, it's a conversation about cost, that tracing is too expensive, either dollars are too expensive or overhead is too expensive. And sampling is maybe one way to look at it, although I think it's better to think about query visibility, which I'll talk about in a second. But the other piece of it is the verbosity of the traces. The whole framing of the question makes it sound like traces have a certain fixed cost, which is complete garbage. So I'll talk, as you get more verbose, or as you want the queries to be more visible for longer, the cost per trace goes up. So you can go along either axis and you end up with something more expensive. If I were to break down trace verbosity, the simplest and most basic thing you can do is just propagate the path that the trace takes. No time, even without any timing information or any of the tags or attributes, that path itself ends up being extremely valuable, which I'll talk about in a minute. The kind of common case is to do that and also to include attributes about, the business logic, like what customer was this, that sort of stuff, what endpoint was it, as well as resource information, like what host was I on, which network links did I traverse, that sort of stuff. So you have transaction resource attributes. And then sometimes you see people attaching what looks like just plain old logs, or even more verbose than that, like kind of micro logging, like verbose logging to the span itself, which I think is very promising. And we've seen some customers replace 95% of their logging with that approach, and that can be pretty valuable, but is definitely beyond just doing latency analysis like we did in Dapper. That's like full-scale log replacement kind of approach. For the query visibility, this gets to what you were saying a minute ago, Ted, that you have you can do kind of queries over parts of the traces, just local statistics about what's happening in the specific process. That can be very valuable, actually, and can replace a lot of instrumentation and logic around metrics. You can query for just recent traces, whether the recent means 10 minutes or an hour, sort of up to the implementer, or you can do queries for truly historical, like multi-week, multi-month horizon historical queries. It's possible to have different sampling rates for each one of these. In fact, it's probably advisable to have different sampling rates for each one of these. And this is something that we kind of skimmed over in the Dapper paper. We talked a bit about Y and Z. We really didn't talk about X, because in Dapper V1, we didn't have it. I think with Lightstep and other implementations, we have found that this can be up at 100. This can actually be up at 100 or close to it as well. And then you only start sampling more aggressively when you're going back in time. So these things can look a lot different depending on what you're optimizing for. But when you take the cross product of these two different axes, I'm not going to walk through all of this, although I'll happily share the slides, but there are use cases that fall into these different buckets. I'm going to highlight a couple, like this stuff right here. When we developed Dapper at Google, it was developed for latency analysis. That project is, I've left Google almost 10 years now, but I believe that project is now staffed out of the storage area of Google, because the most economically valuable thing Google got out of Dapper ultimately was distributed resource accounting and management, where you could bin pack multi-tenant storage systems that cost billions of dollars a year up to 100% utilization by using the trace context to enforce multi-tenant restrictions. So you can say, Gmail is going to use 23.4% of this, and web search is going to use 45.1%, and this tiny SKU is going to use 1% of it. And they use the tracing context to enforce those limits. That allows them to not over provision storage, which everyone else has to do, and that saves them probably hundreds of millions of dollars a year. So this is all distributed tracing. Without distributed tracing, you couldn't do that. But you don't see any traces in the UI. It's not the thing that you think about when you're thinking of Zipkin or Jaeger or something, but it's definitely really, really valuable if you can deploy it. And it requires the same sort of instrumentation and initial investment that the rest of tracing requires. And then what you were just talking about, Ted, being able to do just looking at individual spans, individual fragments of traces, and keep or discard them based on their properties in a tail sampling mechanism. That can be really valuable for understanding local behavior, especially if you include the log. At Google, we had something called request-C that allowed you to look at in-flight requests that were stuck, like on a mutex or some kind of memory barrier within the process, and understand exactly what happened for those requests in real time is enormously valuable. Actually use the same context that we use for Dapper. So it's kind of like local tracing combined with distributed tracing in one. And then, you know, up here, the most expensive thing would be like using tracing to just fully replace a lot of conventional logging with benefits, which I've written about in other places. I'm not going to go deep on that right now. But these are all things that are difficult or impossible to do without distributed tracing instrumentation, in my mind anyway, at least locally, but go far beyond what we consider tracing sweet spot today, which is basically like critical path latency analysis and error analysis in distributed systems. I think if we can have a more dynamic approach to not just sampling, but recognize that there's actually many layers of sampling and there's many layers of verbosity. If we can give people control over managing those trade-offs and optimizing, you know, for which use cases they want, all of this stuff becomes viable. And I think distributed tracing gets a lot more valuable. So sampling is definitely important. I just think it needs to be more than just a conversation about what's my sampling ratio and am I doing head or tail sampling? It's more like which use cases do we want to pursue? And then those force different sampling strategies, and hopefully, you know, the tooling you're using can help guide you, because it gets very complicated. But that's kind of, I think that's, yeah, that's all I had prepared scribbling wise. I know that's a lot, but I just wanted to kind of zoom out and think about sampling in general.
Yeah, that is a fabulous graph, by the way. That's, I think, clears this up for a lot of people. We certainly have both end users and Lightstep customers who come to us, and like you say, they start at, well, what sampling rate should I pick? And the answer really comes down to, well, what are you trying to get out of Lightstep?
Yeah, and I realized that there's kind of a lack of a calculator. So in the world, I'm not very good at math. It's sort of my dark secret, but so I couldn't figure out a way to do this closed form, but I did make, like, let me see if I can make this bigger. I made like a calculator the other day that's meant to help answer these sorts of questions. It's like pretty grotesque. I mean, it has like a bunch of weird combinatorics and stuff like that to build this like side table and stuff, but I think it's correct. At least I went through some worked examples. It seems to be correct. I mean, it's basically like, you know, the situation you find yourself in if you're trying to determine sampling ratios is like, if you just want to look at one trace for something, that's great. But I would suggest that if you want to do real analysis, you need to have many examples that hopefully can be aggregated automatically. So it's like, let's say you're interested in understanding slow requests. So let's say you want to have, I don't know, let's say you want to have 20 examples of slow requests from some, you know, time period during an incident or something like that. And you want to, and slow requests means that like the slowest 5% of them. And there were 1,000 requests during the period you cared about to begin with. So you start with 1,000, 5% of them are actually slow, and you want to have 20 examples when you're done. You can basically use this to say, well, if I sampled, you know, if you did what Dapper did and said, we're going to sample 0.1% of the traces, you have a 0% chance of having 20 of them, right? And at Google, the reason we were able to get away with it is that this number here was like 1 million. Unfortunately, the combinatorics in this spreadsheet don't work with numbers that high, but if you set the sampling rate to 10%, you still have a 0% chance. 25%, if you sample 25% of the traces, you have like an 8% chance of success. But if you get up to 50%, you have like a 95% chance of success, right? So there's a lot of nonlinearities in these things. I'll send out a link to this in the webinar attendees, so you can play with it if you want. And again, it's just like a almost illustrative tool. It's not meant to be perfect, but the thing that's so surprising about it, if you start playing with it, is how nonlinear it is. It's like it's very counterintuitive, like what percentage you need to sample if you want to have a reasonable body of evidence at the end to do your analysis. And I think that's part of the confusion for people too, is that they come with this question like, well, trace, we know 100% sampling is too expensive. What rate should we choose? And it's difficult to come up with like a principled avenue to answering that question, which is what inspired me to start playing with this stuff and to try to make it easier for people to think about. So.
Nice. Do you think it would be feasible in the future to go back to that chart that you made and apply sort of like minimum viable sampling rates to some of these areas?
You know, it's a really good question. I think the problem with it is that, you know, for some of them, it's not random sampling, right? I mean, I think this is something that, you know, some approaches have taken. Like I know with Lightstep, a lot of the sampling we do is kind of just in time and is based more on the query someone wants to run. So if you said like, look, you know, here's my SLO for this service, like we know a priori that anything that is relevant to the SLO is more valuable than something that's not. And so the sampling rate isn't just a percentage, it's influenced by the request path itself. And that's, you know, the percents here are meant to reflect the sort of aggregate percentage taken, not necessarily that you just set a sampling ratio and run. In the Dapper paper, we talked about adaptive sampling as like future work for Dapper. As far as I know, at least when I was at Google, it never really got implemented. And that was like years after we wrote that paper, because it ended up being a really difficult thing to do if you can't like look back on the complete set of trace data after the fact. It was very difficult to implement. And that's how Dapper was structured. It made it difficult to pursue that path. But if you're able to look back in time, even for a couple of minutes, you can do a lot of tricks with totally intentionally biased sampling based on queries that are interesting to the end user of the tracing system.
Yeah, and this is something that I love about Lightstep today, and I imagine we're going to simply do more of, which is for a lot of this, you're not talking directly about setting sampling rates and all of this stuff. Instead, as an end user, you're describing what you're interested in, right? You're saying, I'm creating SLOs for these things. I'm creating historical streams. You're saying, I'm interested in historical data about this particular thing. And you're saying, I'm also interested in having some amount, 100% ideally, of all current activity in the system for firefighting. And by just saying I'm interested in these different things, under the hood, that results in heavy sampling of some things, lighter sampling of other things, in order to meet these requirements that you were laying out in that graph. And that higher level approach of just saying like, this is what I want to do, this is what I'm interested in, feels not just saner, but it leaves so much room underneath it to do really tricky stuff that you would never even be able to do by hand.
Yeah, totally. And I think another piece of it, and we've been talking about tracing since we're talking about sampling, but the elephant in the room is that tracing is usually the secondary. It's typically second to metrics in terms of just like the first port of call. Like usually if you're on call, you're going to be on call because of something relating to a metric going out of, you know, going beyond a threshold or something like that. And sampling can also respond to those sorts of events to say, well, you know, it's a metric about which service. Okay, well, if that service has gone out of its alerting threshold, we're going to sample more of the traces going through it than we would otherwise, and things like that. So being integrated into a larger observability story, I think, is an important cue for a tracing system. But my overall feeling is that tracing needs to be integrated into observability as a whole. It's just a type of data. This chart is meant to illustrate the types of use cases that come up, but many of these things are actually multi-telemetry use cases. Like they implicitly involve metrics or logs or both, and tracing is an important part of that, and the sampling should be adaptive to that.
Awesome. Yeah, and you mentioned secondary system. I think this is another key thing that relates to sampling. You've got, you know, in your top right quadrant here, one of the main reasons why people end up wanting to heavily sample tracing, in my opinion, is because they're already trying to keep all the logs, right?
Yeah.
So they already have this like super expensive logging system, and obviously they don't want two of those.
Yeah, totally. And I think logging really broke when people moved to distributed architectures, because it was already felt expensive. And then suddenly your OpEx, I guess, for logging is proportional to the top line of, the number of requests you're getting at the top of your stack. But the number of log lines you're generating is proportional to that top line multiplied by the complexity of your system. So as you add lots of services, if you add 100 services, I wouldn't suggest that every request is every service. You're probably 10xing your logging volume, but you're not 10xing the revenue the system generated when you made the architectural transformation. So you just can't pay for it. It just doesn't really make sense from an ROI standpoint. I still think logging is important, especially at the top of the stack for kind of BI purposes, but for doing debugging, especially in distributed systems, it's just a very, very expensive way to go about things, and not even very effective, because it doesn't have the context information that you would want to understand, how a transaction got to, actually got to wherever the error is occurring or something like that. You really need the context and the trace to answer that question.
Yeah, and as I think we both agree on, and we've talked about on prior convos here, we really like, in a distributed system in particular, logging just lacks context that you need to even perform basic logging activities. Like just seeing all the logs in a transaction is like just a fundamental thing you want to do. When you find one log, you want to look at the rest of the relevant logs. And as a result, everyone for like the past 5 years have been, whether they realize it or not, kind of DIY slapping a tracing system together with like request IDs and just kind of like painfully like hand tooling a tracing system out of their logging system. And if you can just put all of that logging data as events on your spans and then just record it as traces, it seems to me like you just there's no need for two systems there. And that was really maybe just an artificial separation that came out of just history, basically, not out of any like technical reason.
Yeah, absolutely. Absolutely.
Cool. Well, I feel like we've gone through all of the basics. It would be great to start doing some Q&A here. So y'all, there is a button in Zoom called Q&A, and you can use that to open any questions that you would like. If you would like to just ask a question rather than type it out, feel free to raise your hand and I can unmute you.
And while we're waiting for people to do that, I will say that the content that we've been covering today is focused a little bit more theoretically, I think. A lot of times when we talk with people just out in the world trying to do this stuff, the question is very literally like, okay, look, I get it. Sampling is complicated. Like, what sampling rate should I use? God damn it, So I think for that, I would say, like, rule of thumb, the only reason that I know of to do 100% sampling all the time, if cost is no object and you don't care, then just keep everything. If sampling is needed for cost reasons, the only good use case I know of for doing truly 100% sampling all the time, where you keep it for a long time, is looking at individual sessions of end users in an application. That's difficult to do without 100% sampling, but it's usually okay to introduce some sampling. I think when it gets beyond 1 for 10, you start getting frustrated because something bad will happen that's rare and you won't have any record of it. Usually something bad that happens once will happen more than once, but it doesn't necessarily happen 10 times. So in my mind, like, 1 to 1 to 10, it's kind of a range where you can kind of tinker a little bit. Once you go beyond 1 for 10, it starts getting annoying for people and you end up with some frustration. Like that's just totally a rule of thumb. If you had to like just twist my arm and tell me to stop being academic about it. But that's something, because I do get that question a lot. Okay, we have some questions now.
Yeah, let's go through it. Okay, we'll start with the questions in the Q&A and then pop into some from the chat. So is sampling in Lightstep done on the back end or is it done by the agent? Bit of both, right?
Yeah, I mean, agent is a complicated word, but I think by that, let's define agent to be something that sits in the application runtime or on the same VM as the application process. The thing that we have for Lightstep, which we call an SDK there, which is combined with opentelemetry in many cases, is capable of doing some sampling, but it doesn't do the really heavy lifting sampling where we're like keeping circular buffers and stuff like that. That's done in a process that sits on its own VM, so it doesn't interfere with application. But Lightstep's architecture is designed to, first do no harm, like have no overhead, get the data out of the process, and then do a bunch of co-located storage and compute in these backends that run off of the application process. Hopefully that's helpful. But if there are more questions about that, I think we have some white papery stuff about how do we do it, whatever. Yeah. But yeah.
And I would just say rule of thumb there. My suggestion is that sampling that's done on the client side in the SDK, that's the place you should go to last. Essentially, that's the kind of least intelligent sampling, especially if you're using a system like Lightstep. I would recommend setting Lightstep up, getting it configured, using the more advanced sampling that it has. And then if you really do need some kind of cost control mechanism, that's where you start using that trade-off that Ben mentioned. And people always ask me, like, give me a specific number that's going to be the right number to set these sampling decisions up front. And I kind of agree with you, Ben, that it's kind of like you have to play with it, honestly. You maybe have a hard deck of like, this is the cost I'm trying to get to.
Yeah, and not to get into roadmap, but I mean, I think this is an area where we think there's a lot of opportunity to innovate just in general. We want it to be much more about outcomes where like, well, this is what I'm trying to do, just figure it out. Or this is what I'm trying to do, here's how much money I'm willing to spend on telemetry, go figure it out, and just optimize within the budget. So I think that's the vision for all this stuff. We'll get there. So.
Yeah, don't do it unless you have to, is kind of my response to that.
We had a good question about crash reporting and tracing. Do you want to?
Yeah, let's go for that.
If we remove most of the logs, can tracing handle crash reporting as well? I guess it's doable only with tail sampling then. Really good question. Crash reporting can be like, this request had an error, or it can be like, this process literally crashed, like SegV, it's gone. That kind of crash reporting where the process itself, like it actually, was like killed by the operating system, is a terrible fit for tracing. Because typically the tracing has some buffering involved and the buffer doesn't get flushed, or you try to, but it doesn't get flushed reliably or whatever. And probably demands its own solution. There are a number of them out there in the world that can handle. At Google, it was called death rattle. I remember it was like you kind of capture the last gasp of the process in a UDP packet that was sent out into the void and just hope it would get collected. But for just normal error, like just 500 errors and stuff like that, where the process doesn't actually crash, tracing can be used with tail sampling, or it can be used with the sort of sampling we've been talking about with Lightstep, where we keep a circular buffer of the last n minutes of time. And that's absolutely a cue to say, whatever happened to that transaction, we want to gather everything about it, including the stuff that happened before the error, and we can accomplish that. So, but you're right that head sampling is not a good fit for uncommon errors. You often miss them.
Yeah, I might just briefly say, like, with opentelemetry and I'm sure Lightstep's future as well, we're seeing all of this data together. And so things like crash reporting, I imagine, by running the collector as a sidecar or as another local process, you could see that combined with some trickiness in the SDK eventually getting added to handle this kind of crash reporting properly, and then maybe some helpful after the fact associations with what was going on in that process, basically. But that's in the future. Don't really do any of that right now in OpenTelemetry. Okay. So someone asked a simple, what is the best way to get started? And how do I justify the cost of the Lightstep solution?
I try to make these webinars editorial and not salesy, so I'm going to be pretty quick about this second part. But the best way to get started, I mean, assuming you're running some kind of distributed system, which if you weren't, you probably wouldn't be at this thing, would be to start at the core, like the important part of the system, not in the fringe. Like start with some part of the system that actually is valuable from a product standpoint, and get that piece instrumented with OpenTelemetry. Hopefully, if you're using mainstream language like Java or something like that, you can just use the automatic instrumentation in OpenTelemetry to get that going. And then you'll get some quick wins out of just doing the kind of performance analysis that we were talking about earlier. And that's my answer. The second piece is usually people justify the cost of a solution like Lightstep because it improves reliability, improves performance, and improves release velocity. Like those are the things that people typically use to argue about the budget for these things. And if you have more questions, please send me a note and I can help you with that. But I don't want to turn this into a sales pitch as much as I am tempted to. So
yeah, and I don't mind talking. I do think we should talk about how Lightstep works for sure, but let's maybe not pitch it.
Yeah.
But next up we have, how do you identify the use cases for a given system? What are some of the questions you ask to find out if Lightstep is a good fit? I'm getting people asking us to pitch this thing, or to determine sampling based on the use case. How do you like to identify the pain?
Yeah, I mean, I think typically if you ask someone who's managing a distributed system with microservices, serverless, Kubernetes, any of that kind of stuff, whether they're satisfied with the kind of on-call experience, the answer will be definitely not. I think it's a very, very painful thing right now to be responsible for a distributed system, because observability is still early days for distributed systems. So that's one pain point. And the other is just that these applications are large because they have lots of developers. They have lots of developers because they're absolutely essential from a business standpoint. Like they often represent like the future of revenue generation. And yet the performance and the kind of user experience can be kind of spotty. And so being able to ensure high performance and a high quality user experience is also a really difficult thing to do without this kind of tooling. So those are typically the use cases. In terms of sampling, I would say most Lightstep users don't actually need to think that much about it, which is sort of the point of our approach. I think we've talked about this a number of times, but Dapper forced the sampling question pretty early in the application developers sort of life cycle. Lightstep really tries to make it much more about having a Lightstep user says what they want to accomplish, and then Lightstep will dynamically keep or discard data for long-term historical use based on those guideposts. So the sampling is totally non-uniform in Lightstep, which is very different than the way that sampling is often thought about if you're looking at the Dapper paper or something like that. And in fact, that's one of the main things we were trying to accomplish with the system when we started building it, was to have a totally non-uniform approach to sampling. So I would argue that like a Lightstep user should probably choose the highest sampling rate they can afford for just coming out of the application, and then let the system optimize around that. That's typically how it works.
Nice. So we have this question is not specifically on sampling, but I think it's just a nice quick overview question we could hit. Is there a difference between tracing a dynamically typed language, something built on Node.js, versus something built on Golang?
You want to take that one, Ted?
Yeah, I can take that one, totally. So the answer is yes and no. In all cases, you're trying to get what's called context propagation going, which means that trace has to follow the path of code execution. And a lot of the important code related to that, like the network libraries and whatnot, is not application code. It's often open source or other shared libraries like frameworks and database clients. And so in order for tracing to work, you have to get all of that code instrumented, which means either it comes natively instrumented, which OpenTelemetry will allow in the future, or you're having to install some pre-written instrumentation in order to get that up and running. And if you miss instrumentation for a key library, like an HTTP client, then tracing breaks. So really the difference between these different languages comes down to what kind of tricky, helpful hooks do they have to automatically install this instrumentation for you. So in Java, you have this Java agent approach, which allows us to take all of that instrumentation and just automatically wire it all in. So you don't have to think about it. And in Golang, which is very static and doesn't have those kinds of runtime hooks, it means you have to basically do an inventory of what libraries you're using and what instrumentation is available, and then install that instrumentation by hand. And I would say that that's the only real fundamental difference there, is when you're setting it up, how much work do you have to do yourself? I don't know, Ben, if you have a different take there.
No, I think that's a great summary. Yeah, it's for better or worse, these different languages have very different programming models, and it's the dynamic versus static thing is one. But I mean, for Node, I think the hardest part is just how it's all async, and that you have this context propagation that's just totally rampant in Node, which is one of the hardest things to handle from a tracing standpoint. And there's been a lot of effort by many vendors to try and attack that with OpenTelemetry in Node, but it's not so much that it's dynamic, but the fact that you never block. That's the reason why it's so tricky in Node, I think.
Yeah. Some languages have a context mechanism of some kind. And unfortunately, JavaScript, even though it's a very dynamic language, has the least built out mechanism. You know, in Java and other places, you have thread locals or someplace to put this. In Golang, you have an explicit context object. So you have to pass that around, but it's at least an official, clear way of doing it. And in JavaScript, they've been very slow to add one of these mechanisms. But if you install OpenTelemetry, it comes with like the current best of breed approach. And hopefully that's something you don't have to think about too much when you get started with it. Yeah, and as Ben mentioned, just reading the docs for the OpenTelemetry clients, we have some docs at otel.lightstep.com that should get you started. Okay, so next question. Some companies are still small traffic-wise. Are the different insight recommendations for small to very large, are there a difference in terms of recommendations between small and very large distributed systems?
Oh, yeah. I mean, I think it's just the whole like don't pre-optimize thing, in a word. Dapper's design was very much influenced by Google's scale. And there's this totally like broken idea that if something is appropriate for Google, it would be appropriate for Google or anything smaller, which is just not correct. I mean, Dapper, any system I think is really only appropriate for maybe 3-ish orders of magnitude of scale. Google's processing, their public number, which is lower than the actual number, is 5 billion RPCs per second at Google. Hardly anything in the world is even approaching that. And Dapper is incredibly feature poor because it had to scale to match that workload. What you can do with even a medium-sized system, not to mention a small system, is way more interesting and way better actually than what we had with Dapper. So I think I would just say, like, don't start by immediately sampling. Like, you probably don't need to if it's a small system, at least not up front. Yeah, don't pre-optimize, and enjoy the fact that if you have a smaller system, you probably can get a much more featureful observability system to monitor it. So.
Yeah, 100% agree with that. Jen's asked, is tracing going to substitute logging systems from a market perspective?
Yeah, I mean, this is probably I'm not helping with this presentation by talking about tracing and isolation, but it's all part of a larger sort of schema of observability, which Ted and I have talked about in the past, and I've written about quite a bit. In terms of observability, I would say logging data and tracing data are two types of data that plug into observability as like a solution, right? The logging data is largely used for observability and security. Some of the security use cases, I think, still stand on their own and probably demand a different kind of front end and user experience, but they don't require the same level of detail, in my mind anyway, that you need if you're doing observability. So I think the way I would think about it is that 90+% of the logging budget for a microservices oriented application can probably go away and be allocated much more efficiently, i.e. like with less money, towards a more tracing oriented approach. But tracing is best for transactional logging. So logging about transactions. If you want to log about the lifetime of a process, like a process started, a process died, that kind of stuff, it's not as well suited towards tracing, which is typically more oriented around user transactions than resource lifetimes and stuff like that. So there's still some use case for like a trickle of logs to come in about resources, but that's like, it's got to be less than 1% of the logs out there, right? So again, like in terms of budget, yeah, I think logging is going to be replaced by tracing. If you think about tracing as that large 3x3 matrix and not just that narrow thing that we're doing today, I think logging will largely be replaced by tracing because it's just not as flexible and not as powerful, and nor is it as easy to scale from a cost standpoint.
Yeah, I might add on to that is like, I predict it's also just going to merge into just a big messy blob, essentially, as all the different vendors start to deal with different kinds of data. And OpenTelemetry doesn't really differentiate this stuff. Like it's just one big pipe of data. And if you're logging and a trace is active, then that log will get associated with that trace. If you're logging and there's no trace, then it's not. You have your log levels for identifying something's an audit log or not. And so as an end user, it might not even feel all of that different. So I don't think the word log is going to go away, and people are going to be like, don't write logs anymore, write traces, if that's helpful. All right.
Yeah, I put something in the chat that's like a rant I wrote on Twitter about logs and traces and stuff like that, if people want to read more.
Yeah, it's all about context. Can OpenTelemetry Collector help with sampling decisions across services? That's kind of a yes and no. I just to jump in here real quick, the difference between what the OpenTelemetry Collector can do versus what Lightstep does with microsatellites and these sort of collector-ish things that you run when you're running Lightstep is there's no control plane for the collectors. So the collectors don't have a universal view or a way of doing any kind of complicated decision making that involves having some high level awareness across your deployed fleet of them. And so you can do sampling there. You can definitely do the kind of sampling where you can assemble traces and then retain ones that have errors and stuff like that. But it's a bit limited right now due to the fact that all of that data has to be in one collector in order for it to do something with it. Yeah, Ben, I don't know if you have anything to add there.
Yeah,
great. All right, next up, and we've got time. It's 9:50, so we've got time for maybe 5 more minutes. This sound good? All right. How can I control the sampling in opentelemetry.net? I cannot find any config or document which can help in sampling percentage control. I would definitely take that question to the OpenTelemetry Slack if you're having trouble finding the docs about it. So if you go to the CNCF CNCF Slack instance and make an account there. There's a bunch of OpenTelemetry channels, including an opentelemetrynet channel. That's the best place to get quick help. But if it's also confusing, that sounds like an issue that should get filed on that repo. But the answer is also there aren't a lot of sampling controls at this time. So that's another thing. So yeah, there you go.
There is I'm, to be clear, far from an expert on the .NET SDK, but just doing a little GitHub search, like there is like a trace ID ratio based sampler and stuff like that. Like I see the code exists.
Yeah.
Exactly what flag you pass where, I frankly don't know, because I don't speak .NET, but someone has done the work. So I would say it's I'll put a link to something that will hopefully help in the Zoom chat.
So samplers are also, I would say, implemented as plugins, especially if they're experimental samplers. So that's another place you might want to look. You may have to install a sampling plugin, or the docs may be associated with that plugin, even if it is bundled. So it's great to have a look. Yep, and that's one of them right there. I would also check in on, how experimental some of those things are, because there's a lot of active sampling work going on. Okay. A lot of distributed tracing still seems concentrated on mostly synchronous RPC calls between microservices. The questions and techniques for sampling change for tracing in more event-based systems.
That is a really good question. Yeah, they probably do. And I will, the implied critique is like right on the money. I think that tracing stuff has frankly done a pretty poor job of managing like anything relating to Kafka or other message queues for a variety of reasons. But the hardest one is that often in those systems, you'll end up coalescing sort of two logical transactions into one, and they'll get batched, and for efficiency reasons into two transactions will get in the same queue and will get batched. And sampling does not do well with that. Sampling assumes that you make a decision and it propagates for the lifetime of that request. But when the request lifetime kind of merges with another request lifetime, it doesn't know what to do. So you're right that it's messy. I think it's actually easier if you're doing the type of stuff that we've discussed, where you keep all of the data for some period of time and then look back and make a decision afterwards, which we can do with Lightstep. I think the underlying data platforms are catching up at this point. The UIs have not. I think the UI visualizations for a lot of these sorts of queuing-based systems are, it's basically just a timeline view, but it doesn't really express any of the critical path aspects, which you get with more nested RPCs and stuff like that. So there's still a lot of work to be done there. Yeah. I don't think I can do a short answer to that, unfortunately, but it's a very good question.
Yeah, I might mention just very briefly on the OpenTelemetry side, this is implemented with a functionality called links. So each leg in an asynchronous system will be a trace, and then you can link these traces together into a graph. The trick is most of tracing systems do not yet implement links. So there's a chicken and an egg thing there. And then, as Ben mentioned, there's also the question of like, how should we model some of this stuff for like instrumentation you just want to install and have it go? Like, how do you model batch processing of messages and some of these things? And there is a messaging working group in OpenTelemetry right now with a bunch of subject matter experts actively working on modeling these questions. So if you're interested in that, come check out that working group. Cool. So maybe one or two more. We're getting to the end here. Do you consider kind of reduce data that is older? Maybe there's a way to aggregate high-level data to monitor trends versus keeping all the details always.
Yeah, that's such a good question as well. Yeah, I actually, in one of my diagrams, I had that. And then I deleted it because I was like, this diagram is too complicated already, and I can't add like a third depth dimension about aggregation. But yeah, I mean, one of the most important ways of reducing the cost is by aggregating the data, and there's a lot of different ways to do it. I think that the trade-off there is when you aggregate, you have to aggregate along certain dimensions. And if those dimensions have high cardinality, you've just created a new cost problem. So you either have high throughput costs for tracing or high cardinality costs for aggregations, which are not metrics really. It's much more about just statistics over time, although they look like metrics. So the question is whether you can find low cardinality aggregations to summarize over time. And if you can, that's an extremely efficient way to save costs on the system. It's a great question.
Great. Okay, maybe time for one more. BHS, do you have a question that you want to go for?
Well, I have some friends I see in the list here. Demetrios I've known for a while, and it's nice to see Tom Taman here as well. So I don't know, the questions are also good. I think it might make sense to actually, if we took these and tried to summarize them, and we can to do a little, quick and dirty version of the answer as part of the email we put out after this thing, just with materials. They're excellent questions, and I'm really glad people stayed and attended, and I hope this is useful for people, but it's hard to choose one, frankly.
Awesome. Yeah, I'm copying all of these remaining questions out here. That's a great idea, Ben.
Yeah, in the last 2 minutes, I guess this is theoretically a 30-minute webinar, although we're at the 58-minute mark here. If people have requests for other topics, please send them to us. We're just trying to make this interesting and useful for people, and I hope it is. So anything you all want to hear about, just let us know, and we'll put it in the queue.
Yeah, awesome. Well, thank you everyone for coming. Hit us up on Twitter. I'm Tetsuo. BHS is LBHS. And let us know for future talks, future conversations. If there's particular subjects you're interested in seeing some discussion about, doing a Q&A, let us know, and we'll try to work it in.
And Ted, where's your cat?
Where is my cat? Oh, he's hanging out on the chair back there. You can see him there. He's just chilling.
All right.
Yeah. Cool beans. All right. Thank you so much, Ben. It's always a pleasure.
Thank you, Ted. Thanks, everyone.